Start with the name of Allah, the most beneficent, the most merciful. Today I came with a new video. This video is basically related to hydroelectric power plant numerical. I came up with this numerical and needed to solve it and also share the result with you members. So let's start. First, uh, we shall read the statement. Here is the scenario. So scenario is about a hydroelectric power plant has a reservoir of area 8.5 kilometer square. So here it is given the area of reservoir, because we know that we are solving a hydroelectric power plant numerical, so we should have knowledge about reservoir. This is the basically catchment area behind the behind the hydroelectric power plant, where the water is stored, and it have some height from normal ground. So we may say that it have some specific height from it is higher than our normal ground. Okay, and a capacity of 5 multiplied by 10 raised to power 5 meter cube. So as we know that capacity is given in meter cube, because it is basically the volume. So it is showing us that it has the capacity of 5 multiplied by 10 raised to power 5 meter cube volume. This much water or any other substance can be stored within this reservoir. The tail race is 20 meter high, and again here it is given as height. So we may say that our head is 20 meter. Head is basically known as the height from ground to the reservoir height. So it is basically known as head. So head of our hydel power plant is 20 meter high, and the plant efficiency is 85%. So plant efficiency is also given. What is required to solve? The first point is that calculate the total electrical energy that can be generated if the plant works 5000 hours. So the first thing is to calculate the energy if the plant runs for 5000 hours. Second thing is asked what will be the plant capacity if the load of 150 megawatt supplied by the plant for 9 hours. And the third thing is asked how much water level fall in the reservoir. Actually the third one point is related to second point, because whenever we will be feeding a load of 150 megawatt for 9 hours, this means according to this period of time how much water level fall in our reservoir. So this is the requirements which we need to find. So let's begin. Firstly, let me introduce you some basic formulas which we will be needed to use in our solution. The first one is the power. Power is equal to W mean weight of water, H means height, multiplied by efficiency. So let me tell you, this is the basic formula of hydroelectric power plant to calculate. Although there is another formula which is basically power equal to Q multiplied by H multiplied by G multiplied by efficiency, in which Q is the flow rate which is given in meter cube per second, G is the gravitational force, H is the height, and efficiency is the efficiency of our hydel power plant. So let me tell you first how this formula came up here, so that we do not need to memorize, is we should know the basic concept. Or you may say that if you will know the basic concept, you do not need to memorize it, you will always remember it. So let me tell you first the basic concept of it, this formula. Okay, all we know that efficiency is equal to what, output over input, isn't it? Okay, now in our hydel power plant, what will be our output and what will be our input? In our hydel power plant, our output will be electrical power and our input will be potential energy of water. Actually, what this is also the definition of hydel power plant, which tells us that hydel power plant converts the potential energy stored in water to the electrical energy. How this is potential energy stored in water? Because we are actually, this is a reservoir and we are storing here water, and this reservoir have some height from ground floor, and this height, actually what is this energy, what type of energy is here? If we will be considering it at ground, then we will be having kinetic energy. But as we have studied in our physics classes, that at any height, this height will be any, at any height, if something is available which have a mass, specific mass, and which have a specific height from ground, we will say it that it will be stored, yeah, or it will be having some potential energy. Now what will be the value of potential energy? We also know that the potential energy formula is mgh. Okay, where so in our case the potential energy is in the form of water, so what will be m? It will be m of water. Next, what is this? Gravitational force, and h is height. So we can say that our input will be m g h, and our output will be electrical power V multiplied by I is equal to efficiency. So if we multiply this term here, what will we will get? Efficiency into m g h equal to P, power into electrical form. So here we also know that we can write this formula as it is, but our basic, or you may say that our formula of hydro is replaced here, mg with w. So we also know that weight equal to what? Mg. Weight equal to mg. So we can replace here efficiency into weight into height equal to power. So if you focus here and come back to here, this is weight, this is height, and this is efficiency. It is equal to what? Power. So you may see here efficiency, weight, height equal to power. So this is the basic formula. We do not need to memorize it, or you may have a simple concept about it and you may use it. So up till now we have learned how this formula came. Now the next thing is about weight of water. Now we will learn about weight of water, how to calculate weight of water. So it is basically volume multiplied by density of water. How it is come? It is the basic science formula or physics formula, but let me tell you something about it to memorize its basic concept so that we do not need to okay. Now what we are discussing? We are discussing about weight of water. Weight of water equal to है volume multiply by density. Okay. uh, Sorry, here it should be mass of water, because whenever up till until we would not multiply with g, we will not having the weight, because the requirement of weight is mass multiplied by g. So we are actually we have found here uh, w equal to mg, but from where we will get m, mass? This is what which I am trying to tell you. Okay, here it is mass. Volume, any let's suppose this is the our jar or anything else which can basically store some element, any type of liquid or solid or any type. So what will be its volume? Length, height, length, and width. So it will be the volume of this if we consider reservoir. So it will be the volume of reservoir. If we multiply with it the density of specific specific matter with which we are filling this. If we are filling with it water, then we will definitely considering the density of water. If we are filling it with sand, we will be definitely considering sand. So this is how we calculate the mass. Next is the energy equal to power multiplied by time. This is the well known formula, and no need to explain its explanation. So let's begin with first part. We need to calculate the basic electrical power generated with given data. So if we consider our numerical, at that where we are given height, we are given efficiency, but we are not given exactly weight, or you may say mass of water. We need to find mass of water. So but the main thing is this, that there we are given volume of reservoir. If we go back, this is the volume of reservoir, capacity, or you may say volume of reservoir. So what we will do, we will basically in this formula, this is the thing which we need to find. W is all unknown, H is given, efficiency is given. What is the value of W? W is equal to mass into gravity. Gravity is also known, but the mass is unknown. How we will find mass? Mass of water equal to volume multiplied by density of water. Density of water, we know that 1000 kg per m cube. this is the predefined value of density of water. And now we need volume, and also it is given in question volume. So what we will do, firstly we will find mass of water. It will be 5 into 10 raised to the power 5 multiplied by 1000, this one, and it will become 5 into 10 raised power 8, 3, this 3 and 5 will be add up 8. Now we have the mass of water. We need to find the weight of water, because our actual formula needs here weight of water. So we are considering here 5 into 10 raised to the power 8 multiplied by 10. So we can also take its exact value 9.81 if we are concerned with more exact analysis, but although we take it as 10, and here whenever I have we have find here weight of water. Now we have all the things, required things. We just need to put these things in formula, and we will get electric power generated. Electrical power generated equal to 5 into 10 raised to the power 9 multiplied by 20. 20 is what? The height of water, this one, 20 meter high. And efficiency is also given in 85%, and we know that efficiency is in percentage, but when we will convert it in fractional value, it will become 8.85. We will multiply it, and we got it here. Electrical power generated is equal to 85 gigawatt. Till now we have counted the electrical power generated, but we do not have counted the electrical energy which was required in question. So we will move further. Now whenever we have got the electrical power generated, now it is very easy to calculate the energy for any time interval, because we will simply multiply it with 1000. We will multiply it with time given. So here it was required for calculation of 5000 hours. So power generated multiplied by time. So power is 85 gigawatt, 10 raised to the power 9, and multiply by 5000 hours and divided by 1000. Why we have divided it by 1000? Because the energy unit, there are two energy units, one is joules and one is kilowatt hour. So kilowatt hour is also known as electrical generated units. So when we are dealing with power plants, we normally consider the energy unit as kilowatt hour, unit generated per unit. So here I have divided by 1000, because 1 unit equal to 1000 kilowatt 1 kilowatt hour. If I will not divide it by 1000, then I will be having this value, but it will not units, it will not kilowatt hour, it will be simply joules energy. So whenever I divided by 1000, now I have converted these energy into kilowatt hour, on which our basic electricity units are measured. So I have divided by 1000, and in this form actually I got 425 into 10 raised to the power 9 kilowatt hour, because this 1000 is cut by these 3 zeros, and at the end we have got 425 giga units. We may say that it's units, or you may say that kilowatt hour. We have produced 425 giga units per 5000 hours, during 5000 hours. Now next I will solve the second part of the question. Here it is asked, what will be the plant capacity if the load of 150 megawatts supplied by the plant for 9 hours. Here I have a little objection in this question, because the power plant capacity isn't dependent on load, it is dependent on input, or it is dependent on the rated capacity of alternators or generator which are built in our power plant. So it is doesn't dependent on our load side. So I think there is ambiguity in this question scenario. Either it should be asked in this way, that what will be the plant capacity factor if the load of 150 megawatts supplied. So in this way we will be having actual plant capacity, and we will be also having a load, so we will be divide it and find the plant capacity factor. And the other thing is this, that plant capacity is always in megawatt, but here according to this question it is shown that 150 megawatt for 9 hours. So he is asking about simply to multiply these two things and find the plant capacity in kilowatt hour. So I have basically calculated in this way, but if you have a better solution or you may have a better knowledge about this thing, please correct me in the comment section. I will appreciate your support. So here what I did, here we have connected load 150 megawatt and horse is 9 horse, so we simply generated capacity. Yeah, it will be also quoted in this way, that what is the generated capacity during this load and this working hours, then we will say this is the correct answer. But we cannot exactly tell the capacity of power plant because it is constant, it cannot change with load. So I simply calculated generated capacity by connecting this load for 9 hours with power plant, and this became 135 mega kilowatt hour. Again I have converted mega to kilowatt hour, and then basically when I multiplied 9 multiplied by 150, so it was a big fraction. I converted it into kilowatt hour and I remained same mega here. Third thing is this, that how much water level fall in the reservoir. Okay, now here I used a trick. You will let me know in the comment section either it is true or no. Height of reservoir is equal to x. I supposed the height of reservoir is equal to x, an arbitrary value. X is equal to what? We know that volume of reservoir is what? Length multiplied by width multiplied by height. And in the question it was hint about to use this formula, because the area of reservoir is also given in question and it do not have any use the past two sections. So what we will do, if we divide, basically area is what? Length multiplied by width. So if we divide volume with area, we will get what? Height, because the volume is the combination of three things: length, width and height, but the area is the combination of two things: length and width. If these are divided by each other, so length and width will be cut down and the remaining thing will be height. So I have did this. Volume of reservoir is 5 into 10 raised to power 5. This is given here, this 5 into 10 raised to power 5, and the area of reservoir is given 8.5 kilometer. So I will convert it into meters, because the volume of reservoir is in meters. So 8.5 multiplied by 10 raised to power 3. So now whenever I divided it, so I get x is equal to 58.82 meter. So this is the actual height of our power plant. So what I did next, I considered this height is relevant to this energy. And what is this energy? This energy is the first question scenario energy, where during 5000 hours this energy was produced, 425 giga kilowatt hour. So I made it here. You may say that I basically use the help of fraction. how? Let me see you. We have x value, and we are saying that this x value, this height can produce total energy 425 or somewhat, uh, yeah, 425 into 10 raised to power 9. So this height h basically is x, it can produce this energy. And now we have second energy. What is this energy? This is basically one slide, this 150 megawatt for 9 hours. So we have this energy also. Now the total energy that can be produced with this height is our height is let's tell you our total reservoir height is x, and this can produce this energy. Now the second energy is given for 9 hours, and how much energy is 150 megawatt is load is connected. So what it will basically, what we are doing, as we get energy from the power plant, our this height will be becoming low, because this reservoir will dispatch the water from this to our head and tail race and turbine etc. So actually we have at this height we have this energy, and now we have this energy. We need to find what height reduction occurred during when up till we gained this energy from the reservoir. So we need to we may say that x2, we need to find this height at which we gained this energy. So we have first energy and first height level. We may say that it is somehow this E1 is basically our first energy. So we may make a fraction. What will be x2 if we have E2? E2 is this, we have E1 is this, we have x1 is also known, so we can know that with x2. What will be x2? We will I will show you in solution. So it is the simple, it make a fraction, and this fraction is possible in this way whenever we are dealing with ideal system. So in our numerical we are dealing with ideal system, we are not considering the rest of factors, right? Raining factor or evaporation of water factor and water absorption by land, and there are bunch of other factors we are not considering. We are considering ideal condition. So in ideal condition we may make this scenario that if we have energy at x1 height, so we may simple make a ratio for an other energy at x2 height. So we have built this ratio. So now let's move the solution. Here we have same done with same thing. Fall in reservoir we need to find. X is also given 58.82. It is the total height divided by total energy. So what is it mean that at this height, if this is the total height, this total height can give us the total energy this. Now what we have consumed this energy 1350 into 10 raised to power 3, and from where it come from here. We have basically converted mega into kilowatt hour. 1350 multiplied by 10 raised to power 3, and we have not added kilowatt hour because both units are same and it will be cut down. So we need to find fall in reservoir. So simply what will we do, we simply this cross multiplication with this value on both sides, and we will get answer 0.186 millimeter. So what it is telling about that if we consume this energy from the power plant, we will have a fall in reservoir of 0.186 millimeter. We may also calculate other energies, other values. Let's suppose we are having here 300 or 900 mega into 24 hours, but this energy consumption should be less than the highest possible energy which can be produced from our plant. So this was the solution of this numerical. I might be wrong, I might be uh, miscalculated at any stage. So if you find any objection, any wrong thing, please let me know, please correct me, so that I can build up my concept according to your right way. So thank you.